Hello everyone. So we are back to the design series and today we are going to see the strategy design pattern. So what is a strategy design pattern? It is a behavioral design pattern that lets you define a family of algorithms and you put each of those algorithms in separate classes to make the objects interchangeable at the runtime. So the main objective is instead of hard coding the algorithm inside the class, you just encapsulate them inside separate classes which are called as strategies, so that at the runtime you can interchange those objects. So, just for an example, to understand, let us take an example of an Uber driving system. So, there is an algorithm by which you can determine the closest driver near to your location. So, that is one algorithm. In future, there might be a separate algorithm which can be introduced, which can be much more optimized, and there may be multiple algorithms based on location also. So they should be interchangeable. The developer should be able to change those algorithms easily. So that is achieved via the strategy design pattern. It is one of the most important and highly used design patterns in the system design questions because it highly decouples the code and makes your code scalable. So just think of it like if you are able to change multiple algorithms and in future you are able to change certain part of the algorithm without even modifying the classes. So that is achieving the scalability, and that is the point which the interviewer is looking for. So let us see this strategy design pattern with an example. So we'll be taking an example of a payment strategy and we'll see how we can implement it. So I'll just create a file strategy.cpp hash include iostream using namespace std. Now the first thing I would say that I need an interface for strategy. So class payment strategy. Inside the payment strategy, inside public section, I would need a method virtual void pay. It is going to take an amount, and after that I'm going to have a destructor payment strategy. Now I'll be having certain concrete strategies. They are like you have ways to pay, you have a way credit card, you have a way PayPal. So we are just going to make classes, separate classes for them. Credit card payment, and it will implement the payment strategy. In the public section, I would be having the method pay. It takes the amount, override, and I'll just see out paid amount using credit card. Then the second concrete class will be, say, class PhonePe, and inside PhonePe, okay, it is a class, sorry, public payment strategy. Inside the public section, again, I'll be having a method pay int amount, override, and this time I'll log out paid amount, using PhonePe, handle. Now, after this, I need a context where I'm going to use this strategy. Context. So let us say the context is a shopping cart. Shopping cart. Now, inside the shopping cart, the first thing I would need a payment strategy. So let us make a unique pointer for that. Unique PTR, and it will be payment strategy. Now, inside the public section, I need a void set payment strategy method through which I can set the strategy. Payment strategy pointer s, and I'll say strategy dot reset the s. So we are basically transferring the ownership. So the strategy is not visible in the suggestion. That is because we have to include the library memory. Now, after this, we need a method called checkout, which is going to pay for us. So we'll be having void checkout, and it is going to take an amount. Now, I'll just check strategy. If the strategy is not null, in that case, I'll say strategy dot pay amount. Else, I'll say cout invalid payment method. So with this, the context class is also done. Let us implement main method. So I'll first create a shopping cart, and inside that I'll say cart dot set payment strategy. I'll pass a new credit card payment, and then I'll just say cart dot checkout, and we'll pass the amount, say 100. The next time I'll say cart dot set payment strategy, new phone pay strategy. Okay, we should have kept the name as phone pay strategy. Let us leave it for now. Checkout, say 200. And at the end, we are just going to say return 0. Let us try to compile it and see. Okay, LUDE. And let us see if we have any errors. G++, what G dash O, okay, strategy.cpp dash sat. Okay, strategy.cpp is not visible. Okay, because it is inside the .vs cd.vs code. Let us try to compile it over here. And we have an error in the pay method. So because it is a pointer, so we need to access it via the arrow operator. So we'll just save the file and run it. And when we execute it, you can see the 100 payment is done via this and 200 payment is done via the phone pay method. Now, in case, let us say you want to include some other payment method in future, say there is a Bitcoin method you want to include. So you don't need to modify any of the classes. You can straight away create a new class, say Bitcoin, and inside the publics and publicly you will just implement the payment strategy. And again in the public section, you will override the pay method with int amount, and With this, you can straight away use the Bitcoin class over here instead of credit card or phone pay. So this is the way how you can make your code more scalable and decouple your code so that if there is any more functionality which is required is included or any algorithm is included, you don't need to modify any of the existing classes. So that's all about the strategy design pattern. We'll be coming up with more design patterns in later videos, and then we'll be looking at the system design questions. If you have any doubts, you can ask in the comment section.